Hello everyone, I'm Gani Yadav and welcome to Gani's Law Groove. I hope you all are doing well. Today marks the day 6 of our computer networking journey and let's kick things off. Let's look at our today's topic. First, what is network topology? 2. Importance of network topology. 3. When do we need network topology? 4. Revision of network topology. First, what is network topology? Imagine building. Its blueprint shows the arrangement of rooms, hallways, and staircases, how everything connects and allows people to move around. Similarly, network topology is the blueprint of a computer network. It defines how devices like computers, printers, and servers are connected to each other, forming the pathway for data flow. Think of these connections as roads in a city. A good network topology ensures smooth data flow, like efficient traffic flow on well designed roads. This is crucial for business and organizations to function efficiently. Second, why is network topology important? First, efficient communication. The right topology optimizes data flow, ensuring information travels quickly and reliably between devices. Think of it like having wide, well maintained roads to avoid traffic jams. 2. Easier troubleshooting. When something goes wrong, a clear understanding of network's layout helps pinpoint problems faster. It's like knowing the city map to find the source of traffic jam quickly. Third, future proofing. As technology evolves, network needs change. Understanding topology empowers you to adapt and optimize your network for future demands. It's like building flexible roads that can accommodate increasing traffic. Types of network topologies. So, the division of network topologies are done in two ways. First, physical topology. Second, logical topology. Now, let's look at the physical topology. Physical topology. This refers to the actual physical layout of the cables and connection between devices. There are four main types. First, bus topology. Imagine a single cable connecting all devices like beads on a string. It's simple but can be slow and prone to failures if one device is malfunctions. Second, star topologies. Devices connected to a central hub or switch like spokes on a wheel. This is common in modern network due to its scalability and ease of management. Third, ring topology. Devices from a closed loop with data passing from one to the next. While reliable, it can be complex to manage and troubleshooting can be challenging. Fourth, mesh topology. Every device connects to multiple other devices, creating a web like structure. This offers high redundancy and fault tolerance, but in complex and expensive to implement. Logical topology. This refers to how data actually flows through the network. Regardless of the physical connection, it can be different from the physical topology. Here are four main types. First, bus topology. Data travels in both directions on a single channel, like cars on a one lane road. This can be slow and inefficient for large networks. Second, ring logical topology. Data travels in one direction on a closed loop, similar to the physical ring topology. Third, star logical topology. Data flows through a central device like a hub or switch, similar to the physical star topology. This is the most common logical topology. Fourth, mesh logical topology. Data can take multiple paths between devices, offering flexibility and redundancy. And with this, we are done with our day 6. And if you have any doubts or queries, you can mention them in the comment box. And if you want me to make a video on a particular topic, you can add that topic to the comment box as well. And share this with your friends, like, share, subscribe. And happy networking. Until next time.